So the last section in the unit, the rational functions unit, is solving rational equations. So we'll start with the steps. So the first one is to cross multiply. And if you do not remember doing this in an Algebra 1 class, it'd be something like this. So we would multiply across this way, that's 7x. And then multiply across this way, 2 times 3 is 6. And then we would finish solving by dividing. And so x equals 6/7. So that is how we would cross multiply, or that's what I mean by cross multiplying. Then we are going to move everything to one side and set the equation equal to 0. Then we will factor if necessary. We've been doing that a lot this unit. Then we will solve, and then we need to, at the end, check for extraneous solutions. That means solutions that actually are not solutions. Okay, so if we start with example number 1, we're going to cross multiply this way. So we have x minus 3 times x minus 4. And then we're going to cross multiply this way, which is 1 times 2. So let's go ahead. X times x is x squared. X times negative 4 is negative 4x. Here we have negative 3x. Here we have positive 12 equals 1 times 2 is 2. So step 2 is move everything to one side and set equal to 0. So I'm going to subtract that 2 here, which gives me x squared minus, I can put my like terms together, can't I? So minus 4x, or negative 4x minus 3x is a negative 7x. And then 12 minus 2 is a positive 10. And that now is set equal to 0. So once we've done that, we can factor. So 1 times 10 is 10. Our factors of 10 are 1 and 10, 2 and 5. I want negative 7, so negative 2 and negative 5 will give me that. So I have x minus 2 times x minus 5 equals 0. And so now I'll take each one of these and set them equal to 0 to solve. So when we add the 2 over, we get x equals 2. And when I add the 5 over, I get x equals 5. So now I need to check. And we check by substituting in. So I'm going to substitute 2 in. I have 2 minus 3 divided by 2 equals 1 divided by 2 minus 4. So 2 minus 3, that's a negative 1/2. And 1 over 2 minus 4 is a negative 2. So I have negative 1/2 equals negative 1/2. So that works. So this is definitely a solution. And then if we check 5, we have 5 minus 3 divided by 2 equals 1 divided by 5 minus 4. So 5 minus 3 is 2 divided by 2, which is, 1. And 1 divided by 5 minus 4 is 1. 1 divided by 1 is 1. So that also works. So both of these are solutions, and we have no extraneous solutions. So you will not always have them. Okay. Example number 2. Oh, I'm sorry. I should have put none here. Example number 2. So when we have something like this, we just put the 1 over the 1. And when we cross multiply, 1 times 10x squared minus 10x is just that. And 1 times that is just that. So I'm going to subtract everything over. Subtract or move it, subtract it if I need to. So that's gone and that's gone. So 10 minus 1, that's a 9x squared. And negative 10 minus 2, that's a negative 12x equals 0. And so to factor this, I see that I have a greatest common factor of 3x. So that leaves me with 3x minus 4. Okay. So I'll set each factor equal to 0. 3x equals 0 and 3x minus 4 equals 0. So divide by 3 to get x equals 0. Add the 4. So 3x equals 4 divided by 3 is 4/3. Okay, now we have to check. So if I substitute 0 in here, I have 10 times 0 squared minus 10 times 0 divided by 0 squared minus 2 times 0 equals 1. Basically, that leaves me with a 0 in the denominator. That is undefined, so this does not work. So this is an extraneous solution. Okay, let's check with the 4/3. So I have 10 times 4/3 squared minus 10 times 4/3, all divided by 4/3 squared minus or plus 2 times 4/3 equals 1. So 4/3, that's 16/9. That's 160/9 minus 40/3. And that's going to be 16/9 plus 8/3. So if I get common denominators, that's going to be 120/9. 160 minus 120 is 40/9. And here that would be 3 times 24/9. So 16 plus 24 is also 40/9. So when you have anything divided by itself, it does equal 1. So that works. The other side of the page are 4 practice problems. So this is a good place to pause and then come back and check your work. So for practice number 1, this will give me x squared plus 8x plus 15. And then 5 times all this is 5x squared minus 20x minus 105. If you remember from when we were working with quadratics, we do not want a negative leading coefficient. So I'm going to move everything this way to prevent from that happening. Okay, so that gives me 0. 5 minus 1 is 4x squared. Now minus 28x minus 120. Okay. First of all, I notice that I have a greatest common factor. Okay. So factors of 30, that give me a negative 7. So that's going to be 3 and negative 10. So I have 4 times x plus 3 times x minus 10. All right, so I'm going to set each part equal to 0. Obviously, this is just thrown out. Then I have x plus 3 equals 0, which is x equals negative 3. X minus 10 equals 0, which is x equals 10. And then I'm going to check by plugging these in. So I substituted the -3 in, and I got 0 equals 5, which does not work. So that means -3 is an extraneous solution. Then I substituted 10 into my equation, and I got 5 equals 5, which does work. So that means 10 is one of my solutions. All right, example number 2. So if I cross multiply, I get 3k squared equals k cubed plus 6k squared. And I will subtract this over here to get 0 equals k cubed plus 3k squared. And I have a greatest common factor of k squared. So that leaves me with a k plus 3. So now I will set each factor equal to 0. So if I just take the square root of both sides here, I get 0. There's no plus or minus 0 because 0 is just 0. And if I subtract the 3 here, I get k equals -3. And so now it's time to check. So I substituted 0 into the equation. And again, I end up with 0 in the denominator, which is undefined. So that means 0 is an extraneous solution. Please don't think that because we got it earlier that 0 is always an extraneous solution. It is not. But if you remember from before, you can't have 0 in the denominator. So we already knew that was an excluded value. All right. Then we plug in the -3 to the equation, and I end up with 27 over 27, which it does equal 1. So this is a solution that works. All right. Example number 3. Cross multiplying, I get 5x squared times 4x plus 1. And here I get 1 times x squared. So distribute, that gives me 20x to the third plus 5x squared. And then if I subtract my x squared over here to set it equal to 0, I have 20x cubed plus 4x squared. So I have a GCF of 4x squared. And that leaves me with 5x plus 1. So I will set each factor equal to 0. Divide by 4. So 0 divided by 4 is 0. Take the square root to get x equals 0. Subtract the 1. And divide by the 5 to get x equals -1/5. And now it's time to check. So when I substitute 0 into the equation, I do see that I end up with 0 in the denominator on both sides. That's undefined. So this is an extraneous solution. Now let's plug in -1/5. All right, this was a fun one to do. So I substituted 1/5 everywhere, and I ended up with 1/5 divided by 1/25 equals 1 divided by 1/5. So you have to remember that for division of fractions, you want to change it to multiplication and then take the reciprocal, change, flip. So I ended up with 1/5 times 25, which is 5. And 1 times 5, which is 5. So that one does work, and x equals -1/5 is a solution. Last example. I have all of this multiplied. And then here I have 4 times x plus 5. Now, you could have gone ahead and distributed this and multiplied this first. It will work out either way. I'm just going to put this together as 4x and distribute it. First, let's see. I have x times x squared is x to the third. X times 5x is 5x squared minus x squared minus 5x. And that equals 4x times x is 4x squared. And 4x times the 5 is 20x. So I'm going to minus the 4x squared over here. And I do need to put that together too. I'll subtract the 20x over here. And that will set it equal to 0. So I have x cubed. And then I have 5x squared minus 4. That's 1x squared minus x squared. That's going to actually all go away. And then this gives me a minus 25x equals 0. So I have a greatest common factor of x, which leaves me with x squared minus 25. Hopefully, you will recognize that this is a difference of two squares. And that factors into x plus 5 times x minus 5. And don't forget the x out front. So now I set each factor equal to 0. And I get 0, negative 5, and positive 5. And now it's time to check. So once again, I have substituted 0 in, which leaves me with 0 in the denominator. So 0 is not a solution. Here, I plugged in negative 5 to my equation. And if you look closely, you should see negative 5 plus 5 gives me 0. That's a 0 in the denominator. Right here, I also get 0 in the denominator. So negative 5 is also an extraneous solution. Both of these are. And the last one, I plugged in 5 to my equation, and I've simplified and gotten to 4 over 50 equals 4 over 50. And I can reduce, obviously, but the point is I've got the same number equal to the same number. So that means it does work. That's all I needed. So the only solution to number 4, even though we got 3, the only solution that works is this one, x equals 5.